Let's talk about the last property that we're going to learn about, and then we're going to be able to mix up all of these problems. So this one is the multiplication property of equality. If I know that A and B are equal, and I multiply both sides by C, the same number, it stays in balance. So we remember we were talking about the analogy that our equal sign means that we have our scale in balance. So if I have A is equal to B, and I multiply both sides by the same thing, C, then my equation stays in balance. So as long as you do the same thing to both sides, it stays in balance, okay? And there's actually like websites you could go on and maybe look up, solving equations, balance beam. And and it's kind of fun actually. I can't really show it right here, but you can simulate solving equations by putting little blocks and things on there and like moving them around so that you're showing that you're always doing the same thing to both sides. Okay, with this equation right here, it says 2/3 of x is equal to 12. Now, one thing I want you to realize is if I say 2/3 x, this is really the same thing as 2 times x divided by 3, because x is over 1, right? We were talking about all those implied things. When you see the variable x, what you don't realize is that it's being multiplied by 1, divided by 1, there's a 1 in the exponent, and there's a plus 0. All of these things are going on, and you don't even see them, but they're there, okay? So if I see that I have a fraction, oops, that's 12. All that's happening with the fraction is the numerator is multiplying by the variable, and the denominator is dividing by it. So if I want to say, okay, well, what's the opposite of multiplying by 2? Dividing by 2. And what's the opposite of dividing by 3? And we call that the reciprocal. So if I say, well, I want to divide by 2, the opposite of divide by 2, or the opposite of multiply by 2 is divide by 2. What happens when I take 3/2 times 2/3? What do I get? In other words, 1, 6/6, right? Which is 1. That's because anytime you multiply a number by its reciprocal, I actually always spell it wrong because I say it as reflippercal. One of my students taught me that, reflippercal. Why the reflippercal? Because we flip it. Exactly. So I just undid in one step. And now whatever I do to one side, I have to do to the other. So I'm going to multiply both sides by 3/2. Well, how do I multiply this fraction by a whole number? What's the 12 got going on? It has a 1 denominator, right? You all have 1 denominators too. When it's sunny outside, you go outside, you look down on the ground, you see your invisible 1. Oh, it's like your shadow. 12 has that too. So now we can multiply these across, or do you remember how we cross cancel? So here we get 1x, and here 2 goes into 12, 6 times. 6 times 3 is 18. That was kind of a trickier problem for our very first one. Let's do an easier one. What if I said 5 times a number is equal to 35? And actually, you could play a game, couldn't you? It's like guess my number game. I'm thinking of a mystery number. That mystery number is x. I multiply my mystery number by 5, and the result is 35. What was my number? Does anybody know? 7. How'd you get that? Well, the opposite of multiplying by 5 is to divide by 5, right? So we get x equals 7. And of course, I would want you to check. So here, let's look at the check, because a lot of people will shy away from this because they see the fraction. 2/3 times 18, is it equal to 12? 2/3 times 18, we put the 18 over 1. How many times does 3 go into 18? 6 times, right? 2 times 6, is that 12? 12 equals 12. So that's the check, taking the number that we get for x and plugging it back in. Okay, let's go on to B. What would you do to get x by itself there? This says negative 2 times x is equal to 6. What can I do to get x by itself? We would divide by negative 2 because if you divide a negative by a positive, you would get a negative. And you don't want to be left with a negative x. You want a positive x, right? So a negative divided by a negative gives us a positive x. 6 divided by negative 2 is negative 3. Our check would look like negative 2 times negative 3 is equal to 6. Yes, it is. And there we know it's right. We plugged it in. We checked it, okay? All right. Now we're putting it all together. So we're thinking about all of the different ways that we need to get x by itself. What would you think about doing for letter A on question 3? Yes, combine like terms. I love it. And if we have negative 15 equals, these are our like terms. If I have 2x plus 3x, how many x's do I have? 5x. I don't have x by itself. I'm thinking it's like 5 times some number gives me negative 15. What do I do to find out what that number was? What's the opposite of multiplying by 5? Divide both sides by 5 to undo, right? 5 divided by 5 is 1, which is the reason why we have 1x. Negative 15 divided by 5 is negative 3, right? And if we plug it back in, negative 15, is it equal to 2 times negative 3 plus 3 times negative 3? We get, this is our check, negative 15 equals negative 6 plus negative 9. Anybody who plays cribbage knows that 6 and 9 is 15. All right, so that worked out. How would we get x by itself here? Any thoughts about that one? Yes, the reciprocal. She didn't call it the refliprical, but that's okay. I'll take it. Reciprocal. The reciprocal is what? Love it. 5 over 4, 20 over 1. 20 over 20 is 1, so that's where we get the x. Does everybody see where if I multiply 5/4 by 4/5, you get 1x? Okay, great. That undid. That's the inverse. Multiplicative inverse is the same thing, big fancy word that means the reciprocal. Okay, now what? 4 goes into 20 5 times, right? What's 5 times 5? Good. And here we want to check this. So we have 4/5 times 25 over 1. Is it equal to 20? Oh my gosh. I think it is. Oh, all of a sudden I was freaked out that it wasn't. 5 goes into 25 5 times. 4 times 5 is 20. 20 equals 20. So therefore it's correct. Okay, last problem to do with multiplication. Yes? So because I'm taking the original problem here, 4/5, 5 goes into 25 5 times. 4 times 5 is 20. Right? Oh, I already did that over here. So my answer is 25. This was just my check, plugging it back in. Oh, that's okay. Yes, you did. I was just one step ahead of you. Okay. All right. So for this one, define the variable, step 1. Set up an equation, solve the equation, answer the question in a complete sentence, and then what are we adding to the end? We're always going to add our check. Okay, because somebody asked me the question, when are you going to use this in your real life? Well, you can use checking in your real life, right? You always want to check things. Okay, 7/8 of the audience gave a standing ovation. I don't know why I underlined standing ovation, but anyway. If 112 patrons were standing, how many were in the audience? 7/8 of the audience. The question is, how many are in the audience. So step 1, define the variable. What does X represent? X represents what? It actually is going to answer this question. What's the question asking us? Yes, number in the audience. And the reason why, or attending, let's just do that, attending. The reason why is we already actually know how many people are standing, so that wouldn't really be a very interesting unknown, right? But it's saying 7/8, so most of the audience. How would you write an equation for this? 7/8 of the audience is giving the ovation. Isn't it like this? 7/8 of X equals 112. Do you see how I got that equation? 7/8 of the audience. Okay? And how would I solve this? Step 3, solve. What am I going to multiply both sides by? 8/7. Good. 8/7, because that's the reciprocal. X equals, oh my gosh, I learned a divisibility rule for 7, and actually can't remember what it is. But I learned it recently. 7 must go into 112, I'm assuming. Otherwise, they wouldn't use that number. Well, they might. So divide by 7. Oh, it is convenient. 16. So 7 goes into 112 16 times. 16 times 8 is 128. There are 128 people attending. And then, of course, you can check that. So for your check, you're taking the 128 and you're taking 7/8 of it. 128, is that equal to 112? And I'm just going to trust that it is, but you should always check it. Okay? 8 goes into 128 16 times, and 16 times 7 is 112. Okay, I actually did want to really quickly go back to this problem from the first page. So this problem, a lot of you said you could subtract 9x from both sides. It is true you could solve it that way. Okay, so if you rewrote the problem, 9x minus 2 equals 8x, let's say you subtracted 9x from both sides. You would get negative 2 equals negative x. Notice how I didn't want to do that one that way, because right now, is x by itself? It's not, because it's negative x, right? How could I get rid of the negative sign that's in front of the x? Yes, you would divide both sides by a negative 1. Because remember that this is basically the same thing as negative 1. So now, what's negative 1 divided by negative 1? Well, that would be x, right? Negative divided by a negative is a positive. What's negative 2 divided by negative 1? 2. You see how I got the exact same answer? So there's not one right way to do these. You can sometimes do them multiple ways, but you did need that second tool of multiplication and division in order to get the x by itself. So that's why I avoided doing it that way. So that concludes our notes. The next thing for you to do is to try a lot